Okay, statistics fans, we're going to continue our discussion of the binomial theorem and some of the formulas we can use, also how we can use the calculator. So the topic for today is actually, we're going to solve a problem here, and the question is, will the EKHS girls soccer team win? Before we begin, let me give you your joke of the day. How do you stop a bull from charging? And the answer is, you take away its credit card. Charge credit card. Okay, so here's the situation. When the time runs out in a soccer game and the score is tied, the game will go to a shootout. Each team gets to choose 5 players to kick penalty kicks. Whichever team makes the most penalty kicks wins. If the EKHS, something high school, girls soccer team makes 60% of their penalty kicks, what are the chances they will win the game? Now the first question, is this, number one, is this a binomial setting? Explain. Well, we have a way of checking for binomial. We ask ourselves some questions, and we have to check what we call the bins. And the first letter, the B, stands for, is this binary? Which means, is it success or failure? Are there only 2 options that can occur? And the answer to this is yes, because you can make your penalty kick or you can miss it. So we're going to say, check. That's good. Is it independent? Well, in this case, we will assume that the second kick is not going to depend on the first kick. The third kick will not depend on the second kick. So what one player does in their kick is not going to affect what the other player does in their kick. So yes, that's independent. We need to have a fixed number of trials. And in this case, we're going to take 5 penalty kicks, 5 shots. So n is equal to 5. And then the last thing is, do we have the same probability of success? Same probability. So they say that the soccer team makes 60% of their kicks, so the probability of a make is always going to be 0.6. Which means the probability of a miss is always going to be 0.4. So yes, this is a binomial setting. We have satisfied all the conditions for that. Now, if we were going to work this out by hand, so we have success and we have failure. Success is we make the shot, failure is when we miss the shot, and we're going to take 5 kicks. Now the probability of success is 0.6. The probability of failure is 0.4. And this is raised to the 5th power. Okay, now this is a binomial setting. Okay, so the formula that we're going to use is this right here. Combination, n choose k. P is the probability of success, raised to the k, times 1 minus p, raised to the n minus k. Okay, so the way we're going to play this out here, if we write this down, let's find the probability that we make all 5 shots, that the team makes every single shot. So 5 choose 5, that's a combination, and then it's 0.6 raised to the 5th, and then 0.4 raised to the 0. We're going to make all 5 kicks, which means we're going to miss 0. We are not going to miss any of them. Okay, and above this, I'll go ahead and write down, this is the formula. Okay, combination, n choose k, p raised to the k, times, that's the probability of a make. Now 1 minus p is the probability of everything else, which is a miss, n minus k. Okay, so this is if we make all 5 shots. Well, maybe the team will only make 4 shots. So that would be 0.6 raised to the 4th, times 0.4 raised to the 1st, because we'll miss 1. Make 4, miss 1. This has to always add up to 5, the exponents. Maybe we'll make 3 shots. And so that's 0.6 raised to the 3rd, times 0.4 to the 2nd, plus, so we're adding all these probabilities. Maybe we'll make 2 shots. 0.6 to the 2nd, times 0.4 to the 3rd, we'll miss 3. If we make 1 shot, 0.6 to the 1st, times 0.4 to the 4th. And if we make no shots, if we miss them all, That means it's 0.6 raised to the 0 and 0.4 raised to the 5th. Now, in terms of calculating this, I can use my calculator. I can do each piece of this. Okay, so I can calculate this. That would be the probability. I'm going to fill in the table here, showing the probability of making X penalty kicks. Okay, so X would be the number of makes, that's goals, and then the probability that that happens. Now, the probability that we make 0 kicks is actually going to be right here. Okay, so this is a combination. So I go math over to probability. Now it's NCR, that's a combination. I need to put the number in front. So out of 5 kicks, we're going to make 0. Okay, I'm just going to type this in. And then times, that would be 0.6 raised to the 0. And that would be 0.4 raised to the 5th. And one thing I can do, I'll actually put the combination in parentheses. So I'll come back over here. Okay. And then I hit enter. So the probability that we miss this whole thing is 0.01024. So it's a very low likelihood that we're going to miss all 5 shots. 0.01024. Okay, the probability that we make 1 kick. So I can do this again. So I'm just going to change the exponents. Let me go over to the... So we're going to make 1 kick. So it's 0.6 to the 1 and 0.4 to the 4th. And that gives us 0.0768. Now we could continue to do this, or if you wanted to, you could use binomial PDF. If I go second in the vars key, distribution, and I go down to binomial PDF, that's for 1 value. Now we're taking 5 shots, the number of trials. The probability that we make is 0.6. And in this case, we want to make 2 shots. We want to calculate the probability that we make 2, and that is 0.2304. And just to show you that if I had typed all this, let's see, NCR, we're going to make 2 shots, 0.6 to the 2nd, times 0.4 raised to the 3rd, 0.2304. Okay, and obviously we can keep going with this. Now what we're going to get, just to show you, I've already calculated this, 0.3456, 0.2592, and 0.07776. Find and interpret the mean of the probability distribution, show your work. All right, well, I'm going to use the calculator on this. If I go to stat and edit, here's my list 1. These are the number of shots that I make. These are the probabilities that we make that number of shots. So we can go stat, go over to calculate, 1 variable statistics. So my list is L1, those are the makes, but the frequency list, those are the probabilities. I'm going to put L2 in there and calculate it. And okay, the top number here, x with the bar, that is the mean, and what we get there is 3. So the mean is 3. Now something that's kind of interesting, on the formula sheet, when we have a binomial distribution with parameters n and p, the mean of x is n times p. N is the number of trials, p is the probability of success. Well, we have 5 trials. The probability of success is 0.6, and if we multiply that, what we get is 3. So this is kind of nice that we can use this formula without having to use the calculator. Interpret, we want to interpret the probability distribution. What it means is that after many shootouts, after many times that we do this, where we take 5 penalty kicks, we expect the average number of shots made to be 3. To be 3 out of 5 attempts. Okay, so the mean is equal to 3. Find and interpret the standard deviation of the distribution. Now, on the calculator, I already have this. It's 1.095. So the standard deviation is 1.095, but there's also a formula for this. The standard deviation of x is the square root of n times p times 1 minus p. Now that's 1 minus p is the probability of failure. So the square root, 5 trials, the probability of success is 0.6. The probability of failure is 1 minus that, which is 0.4. And let's see if this works. If I take the square root of 5 times 0.6 times 0.4, and we get, there it is, 1.09544. Okay, so 1.095 is a good answer. We expect, so find and interpret, so what does that mean for standard deviation? We expect the number of goals made or scored in a shootout. We expect that the number of goals made in a shootout typically varies from the mean, which is 3, by 1.095 goals. Okay, we expect the number of goals made in a shootout to typically vary from the mean by 1.095 goals. Okay, so remember, it's not just saying the number, but also interpreting what it means. Number 5, what's the probability that the team scores at least 1 goal? Now, there's a couple of ways that we can do this. The probability now we're saying that x, in the problem, they say x is the number of makes. The probability that x is greater than or equal to 1. Now, the hard way is we could take the probability of scoring 1 plus the probability of scoring 2 all the way to the probability of scoring 5. Or we could take 1 minus the probability. Now, this has every possible situation except for no goals. So 1 minus the probability of not scoring. 1 minus, in this case, that is 0.01024. And if we subtract that, we get 0.98976. So the probability that we score at least 1 goal is very high. Now you could also use binomial CDF if you wanted to do that. Let's take one more here. Let's do number 6. If the other team is expected to make 3 goals, what is the probability that the EK High School girls team wins? Now, if they're going to win, they have to make more than 3 goals. So what's the probability that x is greater than 3? Or the probability that x is 4 or 5? Okay. Now, we could take the probability of scoring 4 plus the probability of scoring 5. Both of these would make this true. And we've already calculated, here's the probability of 4, here's the probability of 5. So we would add those up. So that was 0.2592 plus 0.07776. And if we add those, oops, one too many 7s. There we go. 0.33696 or 0.337. Now that is the probability that the girls team beats their opponent if their opponent makes 3 goals, okay? We could also have done this. Let's say we didn't want to calculate all these out individually, because that would take time to work all of this out, even using binomial PDF. Well, we could do binomial CDF. Now, on my calculator, when I go to distribution, binomial CDF, out of 5, the probability of a make is 0.6. Now, this x value, I am going to type 3. This means it's going to calculate the probability that we scored less than or equal to 3 goals. Now, some of you have a lower bound, upper bound, so you could do 4 and 5, which is what we want, but my calculator only does less than or equal to this value. Okay, so I'm going to hit enter. Now, I'm going to write down, this is 0.63. 5 is the number of trials, or shots. 0.6 is the probability of a make. And this means less than or equal to 3 makes. And what we get is 0.66304. So that equals 0.66304. But that's making less than or equal to 3 shots. We want to make more than 3 because we want to win. So if I take 1 minus that, .33696. 0.337. Okay, so with a lot of these, you have an option. You can use the calculator, but if you do, you need to specify what it is you're doing for that. Or if you've already set up the data, then you can go ahead and use that. And the other thing I do want to do is I want to specify to the graders that this is the probability of making more than 3 shots. And that is the end of part 1.